So picture watching a student, right, just breezing through this advanced algebra exam.
Yeah, furious scribbling, looking completely in the zone.
Exactly. It looks totally brilliant, but then you realize they don't actually know any math at all. They've just, well, memorized what math is supposed to look like.
Right, they aren't applying logic. I mean, they are just drawing shapes they've seen before. It's a complete illusion of competence.
And it falls apart the second you change a single variable. So today we're diving into how AI is finally moving past that illusion. Using a stack of recent research papers on neurosymbolic AI and reasoning frameworks, we're unpacking how AI is learning to actually solve complex math.
Without just guessing, yeah. Because for a long time, standard large language models doing math were exactly like that student.
Just totally faking it.
Basically, yeah. They relied really heavily on supervised fine-tuning, or SFT.
Wait, so with SFT, you're essentially just showing the AI millions of examples, right?
Yeah.
Like a problem and then the correct answer.
Exactly. It's literally handing that student a textbook and saying, just memorize these pages.
Which doesn't teach step-by-step logic at all.
Not at all. The AI is still just doing surface-level pattern matching, so when it faces a multi-step algebra problem it hasn't explicitly seen, it just hallucinates the most statistically likely next word.
Because it lacks any sort of internal self-evaluation to verify if its own math is right.
Right. It is just wandering blindly through the problem.
And if you're wandering blindly, you don't need a statistical guess of where the path might be. You need a rigid map.
Which is exactly why researchers at Princeton decided to build one. They use this thing called GraphMare.
Okay, GraphMare.
Yeah, where knowledge graphs act as, well, implicit reward models. So a knowledge graph basically turns guessing into a strict rule book.
So instead of just sentences, it builds a web of hard facts.
Exactly. Think of a node as a specific math concept, like fractions, and an edge as the strict mathematical rule connecting it to, say, decimals.
So instead of a human grading the AI's math homework, the AI uses those rigid rules in the graph to verify its own steps in real time.
Right. It literally cannot make a logical leap that violates the graph's rules. Researchers actually built this massive knowledge graph using data from ProofWiki.
Oh, wow. Really?
Yeah, they created a map of over 60,000 concept nodes and like 300,000 rule-based edges. It helps the AI safely traverse mathematical proofs without hallucinating.
But wait, math isn't always neat equations on a whiteboard. I mean, what if I give it a messy word problem?
Like a real-world scenario.
Right, like, say, a committee of 5 Democrats and 5 Republicans order coffee. Doesn't the AI get distracted by surface-level words like coffee and just pull the wrong formula?
Well, to prevent that, researchers developed the template theorems graph. So the system acts like a filter. It scans a sentence, identifies the mathematical variables like the number 5, and then it masks the nouns.
Ah, so it completely strips away the coffee and the politician.
Exactly. And it realizes that 5 blank and 5 blank perfectly matches the underlying template for, like, a combinations theorem.
That makes so much sense. It abstracts the whole thing.
Yes. Then it links that abstracted template to the correct theorem. And new frameworks, like one called KG-RAR, take this even further.
How so?
By retrieving the structured knowledge step by step during the actual reasoning process. I mean, it doesn't just pull one formula at the start.
Oh, it checks the map at every single step.
Exactly. So it can't wander off a cliff mid-problem.
Because the map keeps pulling it back.
Yeah.
That is wild.
And it works. This step-by-step retrieval actually boosted success rates by over 20% on rigorous math benchmarks like Math 500.
20% is huge for something as tough as Math 500. So why does this matter to you listening? Because reliable symbolic reasoning turns AI from a toy that drafts emails into a system that can generate error-free financial models.
Or accelerate scientific discovery or write flawless code.
Right. When AI can truly reason, rather than just guess the next word, it becomes a trusted partner in solving really complex problems.
It is a total game changer for engineering and science.
Which leaves a pretty wild thought to mull over. If these knowledge graphs allow AI to perfectly map and navigate human mathematical logic, what happens when these systems start mapping entirely new logical theorems?
Like theorems that human mathematicians haven't even discovered yet.
Exactly. Maybe next time, the student won't just be faking their way through the exam, they will be writing a brand new textbook.